Hello and welcome back, everyone. Our next problem says, give each atom in the following compounds its corresponding formal charge. And we're given two different molecules, so we'll look at them each in more detail. But first, let's recall how we calculate formal charge. So we have a formula saying formal charge, so I'll just put Fc equals the number of valence electrons. And of course, we can determine that by looking at what group our atom is in on the periodic table, minus the number of non-bonding electrons. So are there lone pairs or radicals there? Minus the number of bonds to that atom. So with that in mind, let's go look at our molecules here. So for number one, our molecule in the center has a phosphorus bound to an aluminum atom, and each of those two in the middle has 3 hydrogens bound to it. So the first thing we'll do is look at those hydrogens. There's 6 hydrogens, each with just 1 bond. So they're all going to be the same formal charge. So let's just get them out of the way first. So for the hydrogen atoms, all of them, the formal charge, the number of valence electrons, hydrogen of course just has 1. There are no non-bonding electrons, so -0, and each has just 1 bond, so -1. So the hydrogens all have a formal charge of 0. So we're not going to write anything on the molecule, because since they have no formal charge, you wouldn't need to indicate anything there. If there's no charge indicated, you assume it's 0. So now let's look at the phosphorus atom. Phosphorus is in group 5A. So it will have 5 valence electrons. So the formal charge will equal 5 for the valence electrons minus, there are no non-bonding electrons, so -0. The phosphorus has 4 bonds, so -4. So we get 5 minus 0 minus 4, we get +1. So phosphorus has a +1 formal charge, so we can just put a plus sign next to the phosphorus. And then the aluminum is in group 3A. So its formal charge equals 3 for the valence electrons, -0 non-bonding electrons shown, minus 4 bonds on that as well. So we have 3 minus 0 minus 4. So our aluminum has a formal charge of -1. So we'll put a little minus sign next to the aluminum. And this makes sense because there's no overall charge indicated on our molecule. The positive and negative charges balance each other out. So for molecule number 1, we just have a positive charge on the phosphorus, a negative formal charge on the aluminum. Now let's look at compound number 2. This consists of a phosphorus with 4 methyl groups bound to it. So again, we'll just take a look at the hydrogens first. Recall that each methyl group will have a carbon with a bond to another atom, and then each carbon has 3 hydrogens with single bonds there. So that's what all the methyl groups look like. I'll just put a parentheses and write multiplied by 4. So just like the other molecule in this case, our hydrogens have a formal charge of 1 valence electron, -0 non-bonding electrons, -1 bond, formal charge of 0. So leave them blank. Now let's look at the carbons. Again, every carbon here is in the same situation. All 4 carbons are part of a methyl group, so they have 3 bonds to hydrogen and 1 bond to phosphorus. So for carbon, well, that's in group 4A, and carbon is one that we definitely should just know in organic chemistry. So 4 valence electrons, minus, there are 0 non-bonding electrons, minus 4 bonds for each of them. So we have a 0 formal charge on the carbon. That's right, formal charge equals. So now we just have the central phosphorus left. So phosphorus, we already know from molecule number 1, has 5 valence electrons. So 5 minus 0 non-bonding electrons, minus 4 bonds, equals +1, just like in our other molecule. So the only charge we have here is a positive charge on the phosphorus. So here our molecule is actually an ion. It has the +1 charge based on that +1 formal charge on the phosphorus in the middle. So this is an ion here, a phosphonium ion. So there we have it. We've got the formal charges on our atoms in molecule 1, just on phosphorus, +1, aluminum, -1, and in compound number 2, the +1 charge on phosphorus. See you in the next video.